Hello, guys. Good morning, everyone. So, in the first lecture of P block elements, we discussed around 17 questions, and I tried to tell you what are all the important areas of P block elements and what are the topics which you have to study multiple times before going for exam. And today we have rest of our 17 or 18 questions that we are going to discuss today. And with that, I'll give you some tips to how to remember everything in P block elements because it's a very vast chapter, as you can see in your NCRT. So it takes you so much time if you try to go through each and every area. It will take you so much time to remember everything. Okay, so I'm going to tell you how to crack this chapter, and we'll discuss rest of our yesterday's question. Okay, so with this, let's begin today's session. So, good morning, everyone. I am Sumit Nahak. I had secured All India rank 691 in NEET and currently teaching you chemistry. Okay, so let's begin today's session. P block elements. Yesterday we discussed around 17 questions. So today I'm going to the 18th question. Yeah, this was our last question yesterday. This is this is my question number 18. Question number 18 says, which of the following oxoacids of phosphorus has the strongest reducing property? Okay. What do you mean by reducing property? First, then we'll come to the question. Okay. So first you understand what do you mean by a reducing property? What do you mean by reducing property? Which element will have reducing property? The element which can give hydrogen ion. The element which can give hydrogen ion. Hydrogen ion to another compound. The compound which can give a hydrogen ion to another compound is known as a reducing agent. Is known as a reducing agent. Okay. First, reduction means acceptance of hydrogen or removal of a oxygen is known as reduction. This much you know, I think. Acceptance of a reduction means either accept hydrogen or or removal of oxygen. Acceptance of hydrogen or removal of oxygen is known as reduction. Okay, so the meaning of reducing agent is the compound which is able to give one of its hydrogen to another compound, that is known as a reducing agent. Okay, so to be a reducing agent, the compound must have hydrogen. The compound must have hydrogen, then only it can give hydrogen. Okay, so from the oxo acids given below, what are the oxo acids they have given us? I'll write here H3PO4, H4P2O7, HPO3, H3PO2. Okay, four oxo acids. So which one of the following is a strongest reducing agent? We have to find out. Okay, so to be a strongest reducing agent, how will you know which one is strongest reducing agent? See, one more concept I'm going to tell you here. So please concentrate here. Yesterday I told you to be a strong acid, to be a strong acid, you must have more number of OH bonds. More number of OH bonds. See, guys, inorganic is more about theory. Okay, so whatever I am telling you, just keep it in your mind. That's it. There is no concept behind it. Okay. So to be a strong acid, you must have more number of OH bonds. But in the same way, to be a strong reducing agent, you must have more number of H bonds, single bonded H. Here P is there, so more number of pH bonds should be there. Whichever compound has more number of pH bonds, that will be a strongest reducing agent. Yeah. So to find out which of the following has more number of pH bonds, you must know the structures of all the four compounds. You must know the structures of all the four compounds. So I will draw the structures of all the four compounds. I hope you remember. First, going with H3PO4. How will be the structure of H3PO4? H3PO4. This is the structure for H3PO4. Does it have any pH bonds? No. So it is not a reducing does not have any reducing property. Next in the example we have H4P2O7. P2 H4P2O7. Again, does it have any pH bonds? No. So it also does not have any reducing property. Then going for option number 3, H3PO3. H3PO3. Does it have any pH bonds? Yes, it does. It does have one pH bonds. Then going for the next option, H3PO2. PO2. It has how many pH bonds? It has two pH bonds. Okay. So which one of these two will be the strongest? Obviously, the one with more pH bonds. The one with more pH bonds. That is H3PO2 is the strongest reducing agent. Option number D. Option number D, H3PO2. Since it has more number of pH bonds, it is the strongest reducing agent. Okay. So guys, again, you saw the importance of the structure of these compounds. So please go back and draw the structures again and again so you remember the structures very clearly. So with this, I'm moving on to today's next question. Question number 19. Question number 19 says, which of the following statement is not correct for nitrogen? Which of the following statement is not correct? Not correct for nitrogen. Yeah. So first option is its electronegativity is very high. Is nitrogen's electronegativity very high? Yeah. In the group 15, in all the p block elements, remember this guys, in all the p block element, as you go down the order, the electronegativity of the elements decreases. As you go down the order, electronegativity decreases. So since nitrogen is at the top of the group 15 of periodic table, it will have highest, very high electronegativity is very high electronegativity. Okay, so option A, it seems to be correct. Then coming to option number B, d orbitals are available for bonding. Does nitrogen have a b orbital? Option B says d orbitals are available for bonding. Does nitrogen has b orbitals? I'll draw nitrogen's electronic configuration. Nitrogen is 7, atomic number 7. The electronic configuration will be 1s2, 2s2, 2p3. That's it. There is no d orbital available for nitrogen. Nitrogen does not have any d orbital. Does not have. So this option is not correct. D orbitals are not available for nitrogen. Okay. So this option is not correct. So the question was which one of the following is not correct. So my answer will be option number B. Okay. So what did I tell you? Even if you find the answer in option A or B, please go through option C and D. There might be some more appropriate answer. So for that, I'm going with option C. It is a typical non-metal. Yeah, nitrogen is a typical non-metal. What are the properties to be a typical non-metal? It should not be a solid. It must have high electronegativity. Then it must be a electron acceptor. Yeah, all the properties are corresponding to the properties of nitrogen. So it is a typical nitrogen, typical non-metal. Okay, so this is also correct. Option D is saying the molecular size is very small. What is the molecule for nitrogen? It is N triple bond N. Okay, so this molecule is very small. Yeah, this molecule is very small. So this option is also correct. So I'm left with only one option, option number B. D orbitals are available for bonding, which is not available. So only option which is incorrect is option number B. So go with the option number B. So with this, I'm moving on to the next question, question number 20. Question number 20 says, of the following hybrids, which one of the following has the lowest boiling point? Which one of the following has lowest boiling point? Lowest boiling point. See guys, boiling point depends upon the molecular attraction between the boiling point in a compound depends only on the molecular attraction between them. Okay, it depends. I'll write it for you. It depends only on the molecular attraction between them. Molecular attraction between them. So, if the molecular attraction is more, so if molecular attraction is more, if molecular attraction is more, the boiling point would be more. So these are directly proportional. Okay. If the molecular attraction is more, the boiling point will be more. Okay. So indirectly, you have to see in which of the following four elements the molecular attraction is very, very, very less, which will give, due to which it will also have a low boiling point. So which one of the following will have a low molecular attraction? So again, one more thing for you to remember: in a group, in any group, as you go down for the hydrides, as you for the hydrides of a p block element, for the hydrides of a p block element, as you go down in the order, what will happen is the boiling point increases. The boiling point increases. Why it is increasing? We will see. Okay. So nitrogen, phosphorus, arsenic, tin. Okay. So we will see why the boiling point is increasing as we go down. Why it is increasing? Because as we go down, the van der Waals force, as we go down, as we go down in the group for the hydrides of the p block elements, van der Waals force, van der Well, I hope you know what a van der Waal force is. Van der Waal force increases as we go down. Since the van der Waal force increases, the boiling point also increases. Boiling point also increases. Okay? So according to this logic, the nitrogen hydride, that means NH3 or ammonia, it should have the lowest it should have the lowest boiling point among these four options. But it is not happening. Since the whole inorganic is about what? Exceptions. Here also one exception comes. Ammonia does not have the lowest boiling point. Why? Because ammonia, what it does, if this is ammonia compound, ammonia forms hydrogen bonding. Ammonia forms hydrogen bonds with its compound. Because of this hydrogen compound, it has a very high boiling point. It has a very high boiling point. So ammonia is out of the options. So we are left with what now? Boiling point increases down the order. So ammonia is not happening. So the next in the order we have phosphine, pH3. pH3 has lowest boiling point. pH3 has lowest boiling. Option number C. Did you guys understand what happened here? Again, I'm telling you, as we go down in the order, the boiling point increases. Why it increases? Because of the van der Waal force of attraction between them. Okay. So according to this logic, ammonia should have been our answer. Yeah. But ammonia has its own hydrogen bond, which keep its boiling point very high. So ammonia cannot be our answer. So we are left with next in the order, we are left with phosphine. So phosphine is the answer. Okay, guys. So with this, I'm moving on to next question. Question number 21. Question number 21 says, which one of the following metal evolves hydrogen on reacting with cold nitric acid? So this is again a theoretical question. Okay. On reaction with, you remember this, on reaction with nitric acid, there are only two metals. There are only two metals which, on reaction with nitric acid, evolves hydrogen. There are only two metals. Which are those metals? Those are magnesium and manganese. Magnesium and manganese. Both the name starts with M. Both their name starts with M. Okay. So magnesium and manganese, when reacted with nitric acid, they evolve hydrogen. Okay. So here only magnesium is given. So when magnesium reacts with nitric acid, it will give rise to magnesium nitrate with hydrogen gas will be evolved. I hope it's very clear for you now. Okay. So I would like to tell you about the other reactions of nitric acid. If you have gone through the NCERT properly, okay, there are two more reactions which are very important. The reaction of nitric acid with copper, the reaction of nitric acid with zinc. Yeah. So when copper reacts with nitric acid, when copper reacts with nitric acid, again, guys, there are two more reactions for copper, there are two more reactions for zinc. What are the two more reactions? when copper reacts with dilute nitric acid is one reaction. Another reaction is when copper reacts with concentrated nitric acid. Concentrated nitric acid. What happens when copper reacts with dilute nitric acid? When all these reactions are very important, guys. Please remember this. When copper reacts with dilute nitric acid, it gives rise to copper nitrate plus NO plus H2O. Yeah? But when copper reacts with concentrated HNO3, it will give rise to again copper nitrate, but this time it gives rise to nitrous oxide, NO2 plus H2O. Yeah? Then for the Zinc reaction, when zinc reacts with dilute HNO3, when zinc reacts with dilute HNO3, it gives rise to zinc nitrate plus N2O plus H2O. But when reacts with concentrated HNO3, it gives rise to zinc nitrate again with NO2 plus H2O. Okay, so guys, why this is important? Because they'll give you a reaction from this four equations. They may give you any of the reactions, and they may ask you which one of the following nitrogen compounds, nitrogen gas is being evolved here. Which one of the following nitrogen gas is being evolved here? So if you remember the reactions properly, then only you can write which one of the following nitrogen gases is evolved. When copper is reacting with dilute HNO3, it will give rise to NO. When copper is reacting with concentrated HNO3, it will give rise to NO2. When zinc reacts with dilute HNO3, it gives rise to N2O. When zinc reacts with concentrated HNO3, it gives rise to NO2. Okay, guys? So this question was not given here, but I told you just because there are some students who think these are not important reactions and just skip the question, skip that part, and move on to next chapter. That is why I told you, please go through these four reactions very clear, very properly. Okay. So with this, I'm moving on to next question. Question number 22. Question number 22 says, which one of the following compound does not exist? So to check which of the following compound does not exist, we have to look at all the four options given here. Okay. So first option is NCl5. NCl5. If you know, is nitrogen be able to, can nitrogen make 5 bonds? Can nitrogen make 5 bonds? Is it possible for nitrogen make 5 bonds? No, because it has only 3 electrons extra. See, I'll draw its electronic configuration, then you'll understand. The electronic configuration for nitrogen is 1s2, 2s2, 2p3. Yeah. So this s orbital is completely filled. This s orbital is completely filled. So the only available electrons for nitrogen, for making bonds are these three, the p orbital electrons. These are the only 3 electrons which are available to make bonds. Okay. So it cannot make 5 bonds. It can only make 3 bonds because these s orbital electrons are completely filled. only these 3 electrons are free. Okay, so it can form maximum it can form 3 bonds. But here NCl5, which means they have given 5 bonds for nitrogen, which is clearly not possible. So NCl5 never exists. NCl5 never exists. In the same way, going with the following options, AS5, yeah, arsenic can form 5 bonds because arsenic has D block. Arsenic has a D orbital. Arsenic has a D orbital free. So arsenic can form 5 bonds. Same way, Sb can also make 5 bonds. In the same way, phosphorus can also make 5 bonds. So for arsenic, Sb and phosphorus, it is possible, but it is not possible for nitrogen. So from the following, only NCl5 does not exist. So our answer will be option number A. Okay, guys. So with this, I'll move to question number 23. Question number 23 says, each of the following is true about white and red phosphorus except what? So if you know white and red phosphorus, I'll draw the diagram for white and red phosphorus. White phosphorus, if you know, it has a tetrahedral shape. White phosphorus is a tetrahedral shape. Tetrahedral. This is how a tetrahedral shape looks like. This is our white phosphorus P4. Okay, and our red phosphorus structure is this tetrahedral, but all the tetrahedrals are in connection with each other. This is a polymeric. Red phosphorus is polymeric. This is a polymeric structure it has. All these are connected with each other. Okay, all these are connected with each other. Red phosphorus is a polymeric compound, but white phosphorus is a single molecule compound. Okay, so now I will move to options. Okay, are they except which of the following? Which of the following is wrong? They are asking. Okay, are both soluble in CH2? CH2 means carbon sulfide. Are both white and the red phosphorus soluble in CH2? No, only white phosphorus. Only white phosphorus is soluble. Only white phosphorus is soluble in CH2. Red phosphorus is not. Red phosphorus is not soluble. Red phosphorus is not soluble in CH2. Okay, only white. Please, guys, again a theoretical question. Remember, you have to remember as it is. Only white phosphorus is soluble in CH2. Red phosphorus is not soluble in CH2. Okay, so option A is incorrect. Option A is incorrect. That is what they ask for the question in the question, but we have to go through all the options. Option number B says both of them can be oxidized by heating in air. Both of them can be oxidized by hitting on the air. Yeah, you remember this? The phosphorus is a highly inflammable substance. Phosphorus is highly inflammable substance. Phosphorus is a highly inflammable substance. What does it mean? That means it can be easily oxidized in air. If you expose it to even the slightest amount of oxygen, it will be it will be it will start burning. It will start being oxidized. So option B is correct. Option C says it consists of the same kind of atom. Obviously, white and red both are the forms of phosphorus. So it contains both of them contains same atoms, that is phosphorus. It contains the same atoms, that is phosphorus. So option C is also correct. Now moving on to option number D, it can be converted into one another. White phosphorus, can it be converted to red phosphorus? If you go through the NCERT lines, it is clearly written that red phosphorus is obtained by heating white phosphorus at 573 Kelvin in an inert temperature, in an inert atmosphere, in an inert atmosphere for several days. Okay, white phosphorus can be converted to red phosphorus. How will you convert? By heating it at 573 Kelvin in an inert atmosphere for several days. Then you'll get red phosphorus. So option D is also correct. It can be converted. Okay. So we are left with only option number A, which is incorrect. So answer is option number A. Okay. So guys, with this, I'm moving on to today's next question. Question number 24. Question number 24 says, which one of the following is a nitric acid anhydride? Which one of the following is a nitric acid anhydride? What is nitric acid, guys? Nitric acid is HNO3. Yeah. So, which one of the following is a nitric acid anhydride? What do you mean by this term, nitric acid anhydride? The term nitric acid anhydride means which one of the following compound will be obtained or will be formed when nitric acid is heated? When nitric acid is heated. So, when nitric acid is heated, it will give rise to N2O5. N2O5. Okay? Anhydride means when nitric acid is heated, which one of the following compound will be formed? So, I told you if it is heated, it will give rise to N2O5. In the other way around, it can also be said that if which one of the following compound, when reacted with water, will give rise to HNO3. Again, the same compound N2O5. N2O5, if reacted with water, it will give rise to HNO3. So you understood what anhydride means? Anhydride means if you are heating a compound, that compound should form, and if you are giving water to that compound, the resultant should be the original compound which you started the reaction with. I hope this question is very clear. With this, I'm moving on to next question, question number 25. Question number 25 says, when orthophosphoric acid is heated at 600 degrees Celsius, the product formed is what? What is first an orthophosphoric acid is? I told you in the first lecture of P block element, again and again I told you to remember that. What is an orthophosphoric acid? If you have remembered, orthophosphoric acid is H3PO4. H3PO4 is orthophosphoric acid. So when orthophosphoric acid is heated at 600 degrees Celsius, which one of the following compound will be formed? So if orthophosphoric acid is heated at 600 degrees Celsius, again a theoretical question directly from NCERT, if orthophosphoric acid is heated, it will form metaphosphoric acid. It will form metaphosphoric acid. And what is the formula for metaphosphoric acid? The formula for metaphosphoric acid is HPO3N. And multiple molecules of HPO3 are connected by a polymer ring. Okay, that is only metaphosphoric acid. Okay, guys, so when you hit it, it will give rise to metaphosphoric acid, that is HPO3. So, in which of the following metaphosphoric acid is given? Option number D. Option number D has metaphosphoric acid. Okay, guys. So, again, one more question. This was one more question which shows the importance of the table which I was talking about yesterday. You must be seeing that so many previous year questions have been asked from that one page where a table is given and the structures are given for the phosphorus acids. Phosphorus acids. So please, guys, go back and draw the diagrams again and again. Eventually, remember, start remembering things. It's not a very difficult thing to do. So I'm moving on to next question, question number 26. Question number 26 asks us, which one of the following oxoacid of sulfur has which one of the following oxoacids of sulfur has OO linkage? OO linkage. OO means it is a peroxide linkage. It is a peroxide link or peroxide bond. Okay. So which of the following has a peroxide bond? We have to see. From the following compounds, they have written even the name of the sulfur acids. So from the following name only, you can directly guess the peroxide link can only be present in what? Peroxo disulfuric acid. Peroxo disulfuric acid. Because the peroxide link can only be present in peroxide sulfuric acids. So peroxo disulfuric acid has peroxide link. Option B. This is the smartest way to go for a question, because it will save your time. It will save your time for your rest of your questions. Yeah. But if you want to go through the conventional way, I can draw all the diagrams and will show you how peroxide linkage is only present in peroxodisulfuric acid. So first option is H2SO4. If I'll draw the diagram for H2SO4, this is my diagram for H2SO4. Does it have any peroxide linkage? No. So option A is ruled out. Option B is H2S2O8. If I draw the diagram for H2S2O8, this will be like this. H2S2O8. O8. So this has a peroxide linkage. H2S2O8. This has a peroxide linkage. Option number B, which we already had marked. But coming on to H2S2O7. H2S2O7. Diagram for H2H2O7 will be this. Only one oxygen atom will be here. This is the diagram for H2S2O7. O7. Okay. Does it have any OO linkage or any peroxide linkage? No, it does not have any peroxide linkage. So this is also ruled out. Then option number D, sulfurous acid. The diagram for sulfurous acid will be S, S, a lone pair with his double bonded oxygen with two single bonds. This is diagram for H2SO3. Yeah. So does it have any peroxide linkage? No. This is also ruled out. So we are left with only one option, H2S2O8, which we already had marked option number B. So with this, I'm moving on to next question, question number 27. Again, a more theoretical question. Identify the correct formula for oleum from the following. Oleum. If you have read the NCERT properly, then only you can find the correct answer for this question. Oleum. Open the oxo acids of sulfur in NCERT. Then you can see they have given you four structures for sulfur oxo acids, and in bracket for only one compound they have written oleum in bracket. So which of the following compounds other name is oleum? If you can see, the other name of oleum is for H2S2O7. Okay, H2S2O7. The other name for H2S2O7 is oleum, the sulfuric acid. They may ask you what is the other name for oleum. They may give you option as pyrosulfuric acid, peroxodisulfuric acid, sulfuric acid, sulfurous acid. So you have to find out the correct answer. Okay, so please remember this also, pyrosulfuric acid. Pyrosulfuric acid. Okay, guys. So question number 27 is clear. How to read NCERT told you. NCERT, I'm giving you again, telling you again. NCERT inorganic. Make NCERT inorganic. You have to read at least 8 to 9 times. Along with that, I will tell you, please make short notes of the exceptions, because you'll find plenty of exceptions in P block. Go through the chapter hydrogen, S block, P block, D and F block. You will find a plenty of exceptions. Okay, so it will be better if you make a short notes for the followers for those, because if you have a short note for only exceptions, it will take you very less time for you to revise before the exam. So it's helpful, make short notes for only exceptions, and please try to go through the NCERT again and again. So moving on to question number 28. Question number 28 says, which of the following has a correct thermal stability? Correct thermal stability. Which one of the following has a correct thermal stability? So for the thermal stability, when you go down the order for the thermal stability of hydrates, they've asked you hydrates here now. So hydrates, and they're talking about group 16 of the periodic table. They're talking about group 16 of the periodic table. And draw the group 16: oxygen, sulfur, selenium, selenium, polonium. Okay, so this is the group 16 of the periodic table, and they're talking about the thermal stability of the hydrides. Yeah, so when you go down the order for the hydrides, I'll write it for you. When we go down the order, down the order for hydrides, when you go down the order for hydrides, the bond dissociation enthalpy, the bond dissociation enthalpy, the bond dissociation enthalpy decreases. What does it mean? That means if the bond between hydrogen and oxygen is this, if the bond between hydrogen and polymer is this, the bond dissociation enthalpy for this bond is very less. For this very less. Whereas the bond between hydrogen and oxygen is very strong. It has a very high bond dissociation enthalpy. That means the bond between hydrogen and oxygen is very strong. This is very strong. So to find out the thermal stability, if the bond dissociation enthalpy is very less, that means this bond is very weak. Bond is very weak. So only a slight amount of heat can break this bond. So it has a very less thermal stability. It has a very less thermal stability. You understood why? Because it has very less bond dissociation enthalpy, and because of the very less bond dissociation enthalpy, it has a very weak bond. And since it has a very weak bond, it has very low thermal stability because bond is very weak. Only a slight amount of heat can break the bond. So very less thermal stability. Very less thermal stability. Whereas HO bond is very strong, so it will have very high stability. Okay, so we can also say that as we go down the order, for the hydrates, the thermal stability decreases. Thermal stability decreases. Thermal stability decreases. So the compound with highest thermal stability is H2O, then H2S, then H2SC, then H2TE, then H2PO. Okay, I hope it's very clear for you. Answer will be option number C. So with this, I'm moving on to question number 29. Question number 29 says, in which of the following pair of ions both the species contains SS bonds? Both the species contains SS bonds. So to find out this, you have to draw a diagram. SS bond is present in S2O3 2 minus. First option is S2O3 2 minus. I'll draw the diagram for S2O3 2 minus. S2O3 2 minus. So this will be my diagram for S2O3 2 minus. This is the diagram for S2O3 2 minus. And if you know the polymer of S2O3 2 minus, will give rise to S4O6 2 minus, because the polymer means only if two molecules of S2O3 2 minus is joined, it will give rise to S4O6 2 minus. So both the compounds are nearly same. Both the compounds are nearly same. So if S2O32 minus has SS bonds, S4O62 minus will also have SS bonds. I hope it's very clear for you. In question they asked you which one of the following compounds in which of the following pairs both contains SS bonds. I drew the diagram for S2O32 minus, and you can see it has one SS bond. One SS bond. Okay, and then I told you if S2O32 minus has one SS bond, S4O62 minus will also have SS bonds. Why? Because S4O62 minus is a polymer, kind of a polymer of S2O32 minus. That is why it will also have SS bonds. Okay, so our answer will be option number A. Both the compounds have SS bonds. Okay, and for the other options, option B, option C, and option D, you can draw the diagrams and see they do not have they do not have SS bonds in them. They do not have SS bonds in them. Okay, so with this I'm moving on to question number 30. So now we'll move to question number 30. Question number 30 says the correct order of nitrogen compounds in its decreasing order of oxidation states. Decreasing order of oxidation states. Oxidation states for nitrogen compounds. For nitrogen compounds. And if you see the options, they have given you 4 nitrogen compounds here. One is HNO3, one is NO, nitrous oxide, one is nitrogen, another one is ammonium chloride. So you have to find out in which of the following it has a nitrogen has the highest oxidation state, and in which of the following nitrogen has lowest oxidation state. Okay, so first if I'll write for nitrogen, here nitrogen is one nitrogen atom is bonded with another nitrogen atom. So nitrogen will have an oxidation state of 0 here. Oxidation states, nitrogen will have an oxidation state of 0 here. In the compound ammonium chloride, ammonium ion is present. Ammonium ion is present, which has a charge of +1. So here, if the oxidation state, if I'm assuming nitrogen oxidation state to be X here, X +4 is equal to +1. Did you understand where the plus came from? +4 is the oxidation state of each of the hydrogen atoms. Each of the hydrogen atoms. So the oxidation state of nitrogen will be +1 minus 4 will give the resultant of -3. So the oxidation state of nitrogen here is -3. Then in the compound NO, the oxidation state of nitrogen will be, nitrogen is bonded like this to oxygen. Here the nitrogen's oxidation state will be, since oxygen has high electronegativity. Okay, so oxygen will pull all the electrons towards itself. Okay, so nitrogen will get a positive charge. Positive charge of what? It will get a positive charge of +2. Then in the compound HNO3, we have a ion, nitrate ion, NO3 minus. Here, if the oxidation state of nitrogen is X, -6 is equal to -1. So the value of X will be +5. Okay. So if they're asking you to find out the decreasing order, the first one will be the highest with the highest oxidation state is HNO3, then NO, then nitrogen, and then ammonium chloride. I hope it's clear. Okay. HNO3 has the highest oxidation state, +5. So option number A is the correct answer. So with this, we'll move to question number 31. Question number 31 says nitrogen dioxide and sulfur dioxide have some properties in common. Nitrogen dioxide and sulfur dioxide have some properties in common, but they're asking you which property is shown by one of these compounds and not by the other from the following options. They've given you 4 options and asking you which of the following property is shown by one but not by the other. First option is it is a reducing agent. Are they reducing agents? Do they have hydrogen in them? No. So they are not reducing agents. None of these 2 compounds are reducing agents. So option number A is ruled out. Option number B, they are soluble in water. Yeah, both of them are soluble in water, NO2 and SO2. Coming to option number C, they are a food preservative. Are they food preservative? No, only SO2 is a food preservative. Only sulfur dioxide can be used as a food preservative. NO2 cannot be used. So option C is the answer we were looking for. One property is shown by SO2, but the same property is not shown by NO2. So option C is correct. And the option D is they form acid rain. Yeah, acid rain, NO2 forms HNO3 and results in acid rain. SO2 forms H2SO4 and results in acid rain. So our answer is option number C. With this, I'm moving to question number 32. Question 32 says, which of the following statement given below is incorrect? First option A is Cl2O7 is an anhydride of perchloric acid. Yeah, Cl2O7 is anhydride. Anhydride means what did I say? If you hit perchloric acid, it will give a product as Cl2O7. So option A is correct. You have to find out the incorrect one. Option B says O3 is a bent molecule. O3 is a bent molecule. Yeah, O3 is a bent molecule, if you remember the shape. So option B is correct. Then option C says ONF is isoelectronic with O2 and minus. ONF is isoelectronic with O2 and minus. What do you mean by isoelectronic? Isoelectronic means both the compounds have same number of electrons. How many electrons does it have? Oxygen has 8, nitrogen has 7, fluorine has 9. Total will be 624. And how many electrons does it have? 8 plus 8, 16. Nitrogen is 7 plus 1. Negative charge is 1. So total is 24. So are they electronic? Isoelectronic? Yes. Option D says OF2 is an oxide of fluorine. OF2 is an oxide of fluorine. Is it an oxide of fluorine? No. Since you know fluorine is more electronegative than oxygen. Fluorine is more electronegative than oxygen. So it should be like OF2 is an fluoride. It is an fluoride of oxygen. because fluorine is more electronegative. So option D is incorrect. So they asked you which one of the following is incorrect. So option number D. So now coming to question number 33. Question number 33 says acidity of diprotic acid in aqueous solution increases in the order of what? Again, in a group of periodic table, is they are talking about group 16. In a group of periodic table, the acidity increases as we go down the order. Acidity increases as we go down the order. So here they asked about the compounds sulfur, then comes selenium, then comes tellurium. Okay. So which one of the following will have higher acidity? Acidity increases down the order. So H2Te will be more acidic than H2Se, then H2S. Okay. So answer will be option number A. Okay, guys. So now moving on to question number 34. Question number 34 says, which one of the following does not give oxygen on heating? So now I will heat all the compounds given below, starting with NH4 Cr2O7. Does it give oxygen on heating? If we heat it, it will give to nitrogen plus Cr2O3 plus H2O. Then KClO3, when you heat, it will give to KCl plus oxygen. When you heat zinc chloride, it will give ZnCl2 plus oxygen. Then when you heat K2Cr2O7, it will give K2Cr2O4 plus Cr2O3 plus oxygen. So as you can see the reactions, there is only one compound which does not give oxygen on heating, that is ammonium chromate. That is option number C. So moving on to last question, question number 35. Question number 35 says, sulfur trioxide can be obtained by which one of the following reactions? Sulfur trioxide can only be obtained when you heat ferrous sulfate. Okay? Only when you heat ferrous sulfate, you'll get sulfur trioxide. So answer will be option number B. So with this, I have finished P block element previous year questions. So I hope you enjoyed the session. So please study well. Please study the NCERT properly again and again so that you'll have a very good grip of over NCERT before the exam. So study well. All the best. Good.